Hello and welcome back to another video, and in this video we'll be solving another LeetCode problem. This one is a LeetCode medium problem and its name is unique paths. So let's see what the problem is. So let me just yeah okay. So there is a robot on M cross N grid. The robot is initially located at the top left corner, grid 00. The robot tries to move on the bottom right corner. Okay, the robot can only move either down or right at any point in time. Given the two integers m and n, return the number of possible unique paths that the robot can take to reach the bottom of the right corner. Okay, the test case is generated so that the answer will be less than 2 into 10 1. Okay, so yeah, so let me first explain the question. So let me go here and try to explain what the problem is. Sorry for the bad drawing, but yeah, you can understand it. Okay, so three columns and three rows. We are a robot is here, okay, and we need to go at this is the final destination, and a robot can either go in this direction and in this direction. So it has only two moves. So at each position, it can either go to the right or it can go down. Right? This is what the question says. Let me once again see the question. Right? Yeah, either down or right. All right. So so we have to find the number of ways in which we can reach this final position. So suppose our robot is here, in the next step we go here, and then in another case we go here. So at each position we are having two cases. Now when our robot is here, again we have two choices, either we can go in this direction and we can go in this direction. So so in each case we are having two options to choose from. So as you can see, it can form a recursive tree. Like at each step we can either go down or we can go to the right. So it is clearly making sense to use recursion here, right? So what we can do is, let me try to solve it using recursion first, and then we'll move on to optimizing it further. All right, so we found a number of ways, right? So let me take the return type int, and uh, it's my helper function, which I have named recur, and take index I and j. Will take m, will take n, the given m and n values. All right. Now let me write the base case first. So what will happen if I is greater than m, or j becomes greater than n? Will simply return 0, right? So what I'm saying here is, if our robot crosses this part, right? Or let me again show it in a diagram. It will be better. Yeah, let me do it this way, right? Okay. Yeah. So, so if our robot, suppose it crosses it, like it is going down, right? It is here, and in the next step, suppose it goes here. So this is not a legal place, right? It cannot go out of the boundary. So in that case we'll simply return 0. So this will not make a case. Again, if suppose our robot is here and it now moves in this direction, so again this is also invalid case. So simply return 0 in that case. Otherwise, if I equals to m and j equals to n, what we'll do is we'll simply return 1. So this is a case, that is when we reach the finished position, we'll simply return 1. That is, it will be one of the cases where our robot successfully reaches the end finish point. Now uh, the rest two, now we have to pick like the two options. Like at each position we have two options, either to go to the right or go down. So what we'll do is we'll return 1 plus recur I plus 1 j m and n plus recur I j plus 1 m and n. So these are the two options we have. So no, we don't need one, right? Okay. So let me try to do a return recur 0 0 m and n. Okay. Actually, it will be n minus 1 and n minus 1 because it is 3 and 7, right? So let me run this, see if it's working or not. Yeah. So as you can see, it is working, right? So our recursive code is working. So let me once again tell you the process, like explain it to you once more. So here, this is one of the base case, that if our robot uh, goes in the row direction and it crosses this edge, will simply return 0 because it is an illegal case, invalid case. And again, if our robot moves in this direction and it goes out of this boundary, then we'll simply return 0. In case if a robot just traverses in the legal way and it reaches the finish point, then that path is one of the valid paths, and then we'll return 1 in that case, because it is a valid path and it will add up to our answer. Okay. And otherwise, these two are the base cases, and this one is simply the two cases that a robot has to follow at each point in time. So at each position, it will either go down, which is I plus 1, which is in the row direction, and else it will go in the right direction, which is j plus 1. So yeah, this is the recursion part, and I'm simply returning this here. Okay. So now the problem with this is, this solution is, it is working fine, but it is not optimal. Why it is not optimal? Because in each case we are going either in down or we are going right. So how many positions are there? Since this is of size 3 and this is of size 7 in this case, so there are, total 3 into 7, which is 21 positions are there. Now now consider the case where for each position we have two ways, and so for 21 positions we are having 2 to the power 21. This, my friend, is a huge number. You cannot, like, uh, imagine how huge it is. Let me give you a example how huge it is. 2 to the power 0 is 1, all of you know. 2 to the power 1 is 2. 2 to the power 3, well, 2 is 4. 2 to the power 3 is 8. So each time it is going double, right? So if you go like 2 to the power 10, it is actually 1024 if I'm not wrong. And so you can just imagine like 2 to the power 11, it again becomes 20, like 2048. 2 to the power 12, it becomes 4096, right? So it is becoming double, and you can just imagine how big that number will be. So it is not optimal. So to optimize this, what we can do is we can it is basically what we say that you have to use DP. What is DP? DP. DP stands for dynamic programming. Okay. Now to what we do in DP? In DP, we convert our exponential, yes, exponential problems, like exponential complexities, into quadratic or polynomial, basically polynomial complexities. So as you can see, it is exponential, right? To the power n, it is going big of to the power n. Now we want to convert it into to the power or n square, something like that, right? So how we can do that? We can do that by finding an optimal substructure, and at the same time by by not doing same thing again and again. Okay, so what we are going to do is we are going to memorize. So if you notice here, if you notice here, we are here, right? Now in next step we go here. Suppose in next step we go here again. In this step we have two choices, here and here. Okay, now consider another case. We are now initially we went into this direction. We also can go in this direction as well, right? We can go here, and from here we can go in this direction, right? So you see, we are coming to this position from two directions, and from here we can again go in multiple ways. Now but but before coming to this position, we have we are using different path, but from here our all the cases that we will calculate, we can will it will be same. So what we can do is, once we calculate our all the positions, like all the ways, we can store it in this position, and from here we just need to use it. We can use it like once. We don't need to traverse it again and again. So this is what we're doing. I hope it makes sense. So so what we are going to do is we are going to create an array. uh, Let me, I'll take a vector, you can take an array as well. Vector and vector of int, and I'll call it dp, and I'll assign it n comma vector of int m. Okay, so this is my vector, 2D vector basically, and I'll what we'll do is I'll use it for memoization, right? So let me show you how I'm going to write the code for it. So this is my, oh, sorry, vector of vector of int, and I'm naming it dp, and I'm going to assign m and n. So this is a vector of size m cross n, 2D vector. Okay, and I'm passing it to my recur variable, recur function, sorry. Okay, and here let me dp. Okay, now since these two are the base cases, we don't need to do anything here. But also, I'm initially assigning it with -1. So all the uh, 2D vector is having -1 in it initially. Now, if dp of ij is not equals to -1, that means that if it is not -1, then we might have put some value in it already, right? So that for the answer for that position is already calculated. So we don't need to calculate it again. This is basically memorization does. So we'll simply return dp of ij, and here what we'll do is we'll assign. So what is going here is, first of all, we are going into recursion, and this recursion part will return its answer, where we'll assign it to our current position. And since we already have the answer now, so now in some other cases, if from some other place a robot comes to this position again, it will not go into recursion. Okay, so it comes here, it sees, okay, now my answer is not -1, so it will return simply from here, it will not go into recursion part. Since we are not going into recursion, we are reducing the time complexity. So here the time complexity from 2 to the power n, which is exponential, it reduces to quadratic, which is n square. So now let me, okay, so now let me give it dp dp. Okay, so yeah, it looks good. So let me run it to see if it's working or not. Yeah, it is working fine. So let me submit. Okay, so yeah, as you can see, the answer is accepted. So yeah, that's pretty much it. Thank you for watching. This was unique path. I hope I was able to make you understand. Yeah, see you soon. See ya.